Thanks once again for the introduction, but also for inviting me here. So the topic today will be how to reduce the cold starts for Java serverless application AWS cloud. So we will be focused only on AWS cloud, and we will cover GraalVM native image, AWS SnapStart solution, and also other techniques. So yeah, my name is Vadym, and I have these two passions, Java and AWS, specifically serverless. I'm one of the co-organizers of Java user group Bonn, where I currently more or less live. And I'm also AWS community builder in the serverless category. So that's kind of another opportunity to share the knowledge about that topic, but also insights. You can contact me via various channels. I'm quite active on Twitter and so on. Maybe we can skip. I'm working for the company called AP Labs in Bonn. We have various experiences. I already started as a Java developer in the last century. Then, we migrated into the cloud several years ago and have a kind of mixture of solutions, classical one, Dockerized, but also serverless. So lots of experiences also in the serverless area. But let's dive into the topic. So we will start just to paint the picture where we are and start with the general Java popularity. This conference is Java Focus. So you see from different statistics, you will have different pictures depending on how the statistics are calculated, number of LinkedIn jobs, number of Stack Overflow questions, GitHub repositories. But anyway, you will see that Java belongs to, let's say it's the most popular language for this conference. Let's assume that, but you see it's always top 3, and depending on all the sources. Now we'll dive into the life of Java serverless developer on AWS. We will have the following pictures. So AWS supports Amazon Correta. This is open JDK kind of variant, and they still support Java 8 for bad or good, but it's until 2026 guaranteed. They support also Java 11 if you'd like, but it took quite a while that they started to support Java 17, so more than 1.5 years. So in April, but what the good part is they now, since last Friday, support also Correta Java 21 for Lambda, which has been released only 2 months before. So it's a good sign that AWS keeps up, but they only support long-term versions, which is kind of okay. They will be released now each 2 years, so I think that's reasonable. So that's so far. We know Java is a very fast and programming mature language. We like community, open source, all that stuff. I think it's beautiful. But if you look into Java serverless adoption on AWS, especially like Lambda as a centric part, how you you write business logic, and compare this with the same report from the 2 years before, and now you see Java is kind of, maybe now 11% of all Lambda functions are written in Java. 2 years ago, it has been 4, but it's not the picture we would like to see. You see Node.js, Python, they are kind of ahead and massively ahead. Of course, not very good situation. It has multiple reasons. And the reason number one is that, I would say that stupid cold start. For many applications, doesn't play a big role if it's completely asynchronous. It's then you can wait and all that stuff. But not every application looks like this. So partially, you have this request response pattern, and then you run into that situation where the Java has Lambdas with Java runtime has that significant cold start. First of all, maybe not everybody knows how that all works. This function as a service. So the container that has Java virtual machine can only process one request at a time. And it's like connection that will be then returned to the pool. And then if you have enough execution environments, then they can be reused. Otherwise, the new one will be started. And if you reuse the environment, you reuse the warm environment. If the new one will need to be started, then it's kind of the cold start. That is more or less that part. And for that, we will be looking what does it mean concretely. But it happens for the newer function, or if you change the code and deploy it for the first time, so that then the new environment needs to be created with the new code. But also AWS releases the environments, even warm environments, from time to time to patch the underlying operating system and all that stuff for security reasons. They don't publish how often they do this, but don't expect if you have your warm environments and steady load that they will stay forever. That previously it took several hours and they have been replaced. Now I think it takes a bit longer, but this is nothing to rely on. So generally, if you look into the face of the cold start, AWS has its own CRaC implementation, which is more or less like micro VMs. You can think of like Docker and orchestration, more or less, but AWS uses its own solutions. In case of cold start, then AWS Lambda will start in JVM, in case we select, of course, Java as a runtime. And then this, I would say the Java runtime will load this function, the Java function class, but load only the static initializer block of that. So everything kind of outside of the handler request function, and of course also all these dependencies into that will be also loaded. Very important to know that in this static initializer phase we have the full CPU access for 10 seconds for free for managed Java environment, for managed Lambda environments like Java. There are Docker environments, custom runtimes, they don't belong that you will have that for free, but anyway the full CPU cycle you will have. And it's important to know because normally you select the memory setting, and depending on this, and many select, it will be sufficient to have half of the gigabyte of memory, but the CPU will get proportional to the memory, and the full CPU cycle is only given if you select 1.8 gigabytes of memory that the most functions, Lambda functions, the Java don't need. So if you have kind of half of the gigabyte, you will have only 1.25 fraction of the CPU cycle, which is less. And of course, this gives you the hint that with a full CPU cycle, you can do more. Yeah, simply you just calculate more, and this will be one of the optimization points that we will be touching. And then that's the warm execution, then the Lambda handler method, kind of this, the one function with the business logic that we have, the central one will be called. Yeah, and in the case we have only warm execution, only the last step is relevant. So now let's look into this example application. We have everybody will do something like this in the request response world, like API driven architecture. You have API gateway in front of us, and you have a bunch of lambdas that process the request. In this case, this is more or less like create product, get product by IDs, lambda, get all products, delete products. So more or less generic stuff that we also have on our work. And then we have DynamoDB, like NoSQL managed database, doesn't play any role, but this is more or less the common architecture with more or less synchronous and vacation. It can be much more complicated if we have queues in that, but for that, we assume that. So as Java 21 support has been released several days before, I have remeasured that for 21. I will show you, but let's focus on 17 measurements. So in case you use Java 17, yeah, this is only the cold starts, not the warm invocation. So these are the cold start numbers that you have using plain Java, but also frameworks. Don't pay too much attention to the numbers from the frameworks, because with the new release of Quarkus, that can be a bit different pictures, but you see the whole situation. Only the cold starts is a matter of seconds. Yeah, it may be 2.5 generally if you have some asynchronous patterns or not blocking calls, but generally you will be something between 3.5 seconds and more only for the cold start. Yeah, even without using framework generally adds something on top. And the situation with that is, so you can see this maybe better on that graph. Yeah, it's only the cold start. If you have 3.5 seconds, then add something for the warm execution, add something for the overhead of API gateway to process the request and response. Then you need to render the kind of the response somewhere in the front end, for example, and you can be kind of 5 seconds. And even if it's only concerns 1% of your users, it's probably not a good experience. Yeah, you probably will lose money, you will lose users, and then therefore money, and not a good experience. And you see that by using pure Spring Boot, no native stuff. That's another point. You have the biggest possible cold starts because of all that reflections and all that things happening during the initialization. So the many people try to use Spring Boot, put that into Lambda, and then they were kind of scared about the results and they ran away and say, we only would like to use Spring Boot, and with that cold starts, we cannot proceed. And they're right. So let's first start to look into what you can do more or less easily, but it will, and I think that all that cold starts already include this. If you don't include what I will be talking in that step, then you will probably even get much bigger cold starts. So the first optimization is that you probably don't need this C2 compiler for Lambda, because in case for Java, because it triggers and optimizes the best possible way, but the compiler needs 10,000 invocation of the function, and maybe there will be not so many invocations until the container will be released. So you won't reach peak performance anyway, and that should be another thread that optimizes that, which costs you memory and all the time, so it slows down your Lambda function, and in the end you don't have any benefit. So it's in most cases completely enough to provide these options like stop and tiered stop at level 1. So use only tiered compilation. It will speed up the cold start. Maybe you will have less quick warm invocation, but it's really not noticeable. But for the cold start, it's important not to have these processes optimizing that heavily your performance. Also, of course, that since years is known stuff, use the newest SDK version 2.0, not the old stuff. It's more modular, and you can, in case you need to communicate into the outside of the world, you can use AWS own asynchronous HTTP builder. The same stuff if you use like Apache One or Netty, it's more for long-living applications. It just, in order to initialize all that libraries and they use caching and also on in the Lambda world, it will cost you time and performance. And for the short-lived Lambda functions, it's just not worth doing. That's why AWS developed its own asynchronous client, which is more lightweight for that situation. It took 3 years to come from the preview into the kind of general GA state, which they reached in February this year. But anyway, in case you need to communicate outside of the world and outside of AWS services, this is the way to go. You can configure it, but this is asynchronous client. You need then the whole asynchronous communication chain and use asynchronous client for DynamoDB and all that stuff. So this implies that as well. Also, it's important for Java functions to have as small as possible packages, because for the cold start, they will be downloaded from S3, and that will take you time, and the initialization phase will take longer with the bigger packages. So only include what you really need. It's always the best practice, but if you use long-lived application, we sometimes forget and include all possible open source libraries there. So in this case, simply if you only need DynamoDB or S3, then please include that, and no dependencies for testing that you need on your kind of runtime, only for testing. So consider this as well. So there are also other best practices. For example, if you build clients, like in that case, we use DynamoDB from Lambda, you have to build it. You can skip several parameters, like region, like credentials. AWS can figure it out for you. They know in what region you deploy, and there is a chain of credentials. They go through that chain, try to see where your credentials are, but it also takes time. You know in what region you deploy, you know where how you provide the credentials, if you provide maybe IAM role. So please provide it explicitly. It will save you several hundred milliseconds if you build the clients like DynamoDB, SQS, S3, and all that stuff. Also, it's a good, now we're coming back to that best practice that we utilize the fact that we have this, in this static initializer block, the full CPU for 10 seconds, and even for free, put the stuff that needs to be done once. It's always a good practice outside of that handler on the handler function to speed up initialization anyway, and just to reuse this stuff. For example, like building AWS client needs to be only done once for the life cycle of the Lambda function. So there is one more, and that becomes ugly. So this is poor educational stuff, but it will play a big role further. This technique is priming, and for example, if you do the first call to DynamoDB, yeah, like get item, the situation is that behind that is, for example, JSON marshaller. And this JSON marshaller needs to be initialized the same as a HTTP client, and it takes time. It takes nearly 800 milliseconds. For long-living applications, it's one per kind of execution life cycle. But for the Lambda function, it may be kind of also heavy. So in case your Lambda function has less CPU than one full cycle, you can fake that call in the static initializer block as well. You don't have the ID, so you can fake it with ID 0. You're not interested in the result. The thing is you're interested in warming up Jackson Marshall and that use case. It can be some other stuff depending on what you are using. You need to understand what's behind. That's a situation, but you can speed up the thing in the static initializer block using this full CPU cycle, and it's even for free. Yeah. So this is kind of the trade-off. It's ugly because it's just adding code, but it helps, and it will play another role if we will be talking about the AWS SnapStart in other contexts. But generally, yeah, all that stuff is not for Lambda. No reflection, runtime, bad code generation, dynamic class loading, all that stuff. It's not for this world, for this quick execute and reuse the environment. Of course, people using pure Spring, maybe you use Juice from Google, say just don't work around that because we more or less don't need all this, or it's not a good practice to use that frameworks there. So now start with the GraalVM. It enters the scene. Everybody knows what it is. We don't need to repeat it. So many talks. But what's interesting there, this is this substrate VM. Yeah, which is more or less ahead of time compilation, which is optional on top of GraalVM, but for the serverless world is the important optimization. And this is more or less close world assumption. You need to build native executable image with everything included, like reachable method, fields, classes, and all that stuff. And GraalVM supports Windows, Linux, and also Mac executables. The situation with AWS is it doesn't support kind of managed GraalVM. It supports managed Java, and GraalVM native image is just something else, but it helps you to reduce cold start, and also native image consists only what you need. It's pre-compiled for the native format. It also utilizes less memory. So how to do that? AWS has several solutions. As once again, doesn't provide GraalVM, but it provides custom runtime. And with that custom runtime, you can deliver the native executables as well. AWS specifies that format. It should be only Linux executables, but anyway, it's more or less like format function zip. In that, you have the bootstrap file, which then consists native image, which in case of GraalVM will be GraalVM native image. So this is the one thing how you can use GraalVM. You can do another way, like use container image and Docker container image. Yeah, that's also supported by Lambda, and then pack the GraalVM native image within the Docker. A bit strange way, but it will work. And also AWS now delivered this Amazon Linux 23 edition, and it should be the base for the future also to build their GraalVM native executables. They will provide maybe some help with that. It's quite a new stuff, so we don't really know how it will help, but AWS writes in that publishing article that it will kind of ease the stuff. Let's wait. So now, okay, now we have GraalVM. It's not about exactly how just all the steps, but if we will deliver this with GraalVM native image, what will that mean for the cold starts? Yeah, and it means a lot. Yeah, you see there the same stuff, more or less, Quarkus, Micronaut, Spring. It's not about who is the best or second best, depending on the minor version, it may change, but you see the results. Without using all that frameworks, you can go down more or less. This is for P90. I have the numbers also for P50, 99, all that stuff, but you see you can be somewhere 500, 600 milliseconds. And I think it's acceptable. If you use GraalVM native image, Python, Node.js, there may be somewhere between 300 and 400 milliseconds. And in that area, that's okay for the cold start. Yeah, it only affects small percentage of the users. With that, I think you can leave. But of course, you can have these side effects. Yeah, you're using open source libraries. They are also having dependencies to other open source libraries. So basically, you don't control very well what libraries you use. And if one of that libraries will heavily use something on the fly, like clause loaders and so on, that if you are not aware of it and cannot give a hint to GraalVM, you may run into trouble. For that, GraalVM page, there is this page that contains the GraalVM ready native images so that you can see what libraries are more or less free to use, and this also contains then the dependencies to this library. So that's the hint, but of course, many open source libraries have been built with reflection in mind, and they need to adopt to be kind of GraalVM ready. So you may run, depending on your situation. So also AWS SDKs are GraalVM ready, but sometimes you do something that it's probably not. So, but general conclusion, of course, the 6-7 years of development of GraalVM, really powerful solutions, but of course, and it reduces cold starts, you see, it also reduces memory footprint, which also will reduce your Lambda bill, which is another point why sometimes others prefer other languages, but it has also its challenges. Yeah, for example, Lambda custom runtime requires only Linux executable. It's AWS constraint, not GraalVM. They can provide you also other stuff, so you need to build then only Linux executable. So the question is about the local experience of people using other platforms and would like to test locally. Also, building custom runtime requires effort. You need to build it on your own CI/CD, and it sometimes requires 6-8 gigabytes of memory to build like this custom runtime with a function to deploy. And sometimes you have serverless application, hundreds of functions. You can package some of them together, but it's a huge effort. Yeah, to have these pipelines in parallel running, you need to calculate how much memory do you need. Yeah, this is what you don't have if you have Java runtime, more or less. Yeah, it's completely managed by AWS, but now you have to manage this custom runtime by your own. Yeah, in case of custom runtime, you also pay for this init phase, but it's really small amount. But the scaling the pipeline may be challenging. So it's up to you to use it or not. There are so many good experiences of that. So there's always a trade-off. But let's talk about another technique. So personally, I thought that AWS will release managed GraalVM native image solution, yeah, for Lambda, that the people can easily use GraalVM and don't care about that pipelines. It has, of course, also challenges how to do that if sometimes something doesn't work, how to get the feedback. So there are caveats with that, but they did, as they announced that on the last reInvent, which is basically 1 year ago, they did it differently or provided the improvement differently because they know cold starts in Java, they lose the community, they needed to develop something. And this is so-called AWS SnapStart solution. So what is that? So generally, with that AWS SnapStart, the phase how Lambda is kind of deployed and invoked is just, you see the split. So there is some addition to the deployment phase. If you deploy the function, there is some addition to the invocation. And you see this create snapshot was added in the deployment phase. And there is this restore snapshot that was added in the invocation phase, in each invocation phase. So let's forget this pre-snapshot hooks, post-snapshot hooks. They are optional. We will be talking about them. But what are those snapshots and how they can help? So the snapshots, the Firecracker micro VM create and restore snapshots. So the whole micro VM will be snapshotted and then restored during the invocation phase. And of course, the idea behind this that's the restore phase will be much quicker as a regular cold start. Otherwise, it doesn't make any sense. So they assume that if they restore the whole micro VM with JVM inside, it will be better than 3 seconds cold start. Yeah, and this is based on CRaC. You probably had a lot of talks about CRaC, and we will see how AWS uses CRaC, but it's more CRaC, like checkpoint restore in the user space. CRaC also uses it, but AWS more relies on CRaC directly. It's even more on top. Yeah, and probably everybody knows currently what is that. It's available since 2012, more or less for migration of containers. More or less, you simply migrate that to another machine. And of course, the full context of process should be safe, counters, registers, stacks, memory, shared memory, everything. And the idea is that you can restore the application somewhere on the another machine and continue from that point in time. So similar to CRaC, but CRaC only talks about JVM, and Creo talks about the more or less the whole operating system, and MicroVM has even more. But of course, it has challenges. Open files, network connections. If you just somehow create snapshot and then restore, but who is creating all that stuff somewhere in the static initializer block? It has also challenging with the system clock, and also time-based caches are not very well suited. For example, you will create the snapshot with Creo or with Micro or with CRaC, which contains which only saves the value for 10 hours. Yeah, and then you do, for example, the restore after 9 hours, the value is there. You do restore after 11 hours, and the value is expired. So kind of weird behavior. So you should probably forget or just don't use time-based caches in case you will use SnapStart, for example, which is based on Creo. But generally, the SnapStart gives you an option to configure that on the function level. It's up to you. You need to actively activate that on the Lambda function, which uses Java runtime. Basically, if you followed my presentation before, I provided you some like this restore phase you see here. So how it looks like. If you deploy, then the snapshot will be taken. You will see something like this init runtime. So the function initial, so this init phase will be called in the deployment phase of the function, which prolongs this deployment phase, and you will see something similar in the log. Like you see, if you activated SnapStart, init start means, okay, there the snapshot phase has begun. And in case you have SnapStart and you do the real invocation, you see something like restore report. How much did it take? In my previous presentation, I showed that picture, and it looks, the restore phase is only 35 milliseconds. It's pretty quick. But in the end of the presentation, I also added we could not identify 5 to 6 to 700 milliseconds if we measured the latency between API gateway request incoming and then response going out. And we knew with the communication with AWS that they say that the time shown here, they could not capture the whole time needed for the restore. That was kind of engineering problem. In September, they fixed it. Now we have the real full time of restore. I can say this is the time for restore. You see 689 milliseconds, which is much, it's not ideal, of course, but it's much quicker as a real cold start with a 3.5 seconds. But now you have the real numbers, and you cannot guess where these numbers, so where this latency is kind of disappeared. And if we measure then the whole call start, now without any optimizations, you will see that we are something in between. We are much lower than the regular call start, but we are much higher than GraalVM native image call start. So you see here the values without any frameworks. It's something, you only saw 600 milliseconds. It's only for the restore of the snapshot. There's more just to in the call start phase as only that, and you will be somewhere with that 1.7 seconds, which is half of the time without that, and it's only activating SnapStart. You don't need to do anything more, which is quite good. Only activating, and you just 50% quicker. But it's not the whole story. Of course, it's not very acceptable in 1.7 seconds. It's nice to have that below 1 second. And now we will see what's additionally there, and these are optional snapshots. And these snapshots are based more or less on CRaC API. They are optional, and everybody knows what's CRaC and all that stuff. Hopefully, more or less the same stuff with Creo, but on JVM stuff. But once again, Lambda only use this CRaC APIs. And what you can do with that, this adds you two methods, like before checkpoint, before the snapshot is created, and after restore, so after the snapshot is restored. And once again, before checkpoint is called, executed in the deployment phase. So it's no real impact to the real invocations. And this is the very good place for this kind of priming that I told you. You can add something like priming, like calling DynamoDB, pre-warming injection marshal. It's now a very good point because it's in the deployment phase. It takes a bit longer, but in the case of invocation, the pre-warming stuff is already contained in the snapshot. And if when it's restored, then you don't need to pre-warm, so you save time. So more or less, you see after restore, you don't have any logic. You can add something, but I don't use it personally. But I heavily use, in case of standard applications, this before checkpoint to do this technique called priming. So all other frameworks, Micronaut and all that, they also support that. They have some wrapper around that interfaces, but more or less you will ask, okay, if I can use priming, and not every application can use it. In case of DynamoDB, everybody knows, but maybe you are not using it. But in case you can, and in this concrete example, you see using priming reduces the cold start significantly, using SnapStart and DynamoDB priming significantly. I'm now with something 700 milliseconds with that. With other frameworks, it's a bit more, but it's now real better. We are a bit higher than GraalVM native images, but once again, with copying one more or less one line of code, you can improve that significantly. So it's more or less currently the end game if you use Lambda, pure Lambda without frameworks. Close your eyes, don't look what I will be showing you now. You can improve this in case you are using frameworks like Fokus, like Micronaut, like Spring Native, and the improvement is ugly. But I tested this. If you follow my blogs, you can read about this. I can improve that by doing priming of this mapping, more or less. If I use Micronaut, so use Micronaut annotations, they need to be translated into Lambda invocations, more or less, or principle. So there is kind of this layer in between. Yeah, in the end, it's a pure Lambda, but I program in the Micronaut annotation, all that stuff. And what I do in priming, I wanted only to test if it will work. I simulate this call during the deployment phase. So I pre-warm all that classes that are involved in this translation of annotation models and all that stuff, simply just wanted to look, can I improve it any further? The same pattern is working for Quarkus and Spring Boot, and the code is similar. You can look into this URL. I described that. Basically, what you would like to see how it can improve. Yeah, it improves a lot. This is kind of SnapStart with framework web model priming, I called it. Yeah, so I just translate the web model of Micronaut, Quarkus, Spring Boot to Lambda one. And now you can also improve all this also for the frameworks. I don't recommend to use it. It's too much boilerplate code, easy to write, but it's ugly. But it shows that there is a way also to use that frameworks and go nearly beyond 1 second. Yeah, and I think that's okay, but it's only for the presentation purposes. So now let's look simply into only Java. Yeah, no, you even see here P50, P90, and P99 without frameworks, pure Lambda, that you see the comparison, the pure Lambda without any techniques, like SnapStart and GraalVM at least. The cold start is quite huge, but you need that optimization technique that I told you. You can apply them for that. GraalVM delivers the best performance. AWS SnapStart kind of somewhere in between, but if you can use priming like for DynamoDB, you can, at least for pure Java, you can go beyond 1 second, even for P99, which is, I would say that's for the most cases, it's okay. So Java 21 support was released last Friday. It was for me time to block again and use the weekend, not for my family, they don't hear, but for remeasuring. So now you see more or less the same result. Similar Java 17, Java 21. This is for the pure Java, so without GraalVM. So you see a bit different story, but at least high cold start. If you use SnapStart, they are kind of comparable. I saw that P99 was higher with Java 21. I don't know why. It's a bit higher. And if I use SnapStart with priming, it's also more or less comparable, but P99, these yellow ones, were a bit higher with 21. So, but not significantly. That's, I think, more or less okay. I was also expecting with the SnapStart to have comparable results because It doesn't depend too much on the Java version. You make a snapshot of the whole VM, micro VM, and then restore. So Java VM doesn't play a huge role in that. But anyway, so also SnapStart has its challenges, limitations. It supports from Java 11 on, so no Java 8 support should be okay. Deployment phase will be longer because the snapshot will be taken and then stored, layered in in all regions supported by on the availability zone, supported by the region, like in Frankfurt AWS, in Frankfurt EU Center, there are 3. It takes now, I remeasured this 2 minutes, 15 seconds. As SnapStart was announced, I measured 2 minutes, 40 seconds for one Lambda. If you have many Lambdas deployed in parallel, then this snapshot will be done also in parallel at several seconds, but it's not that at 2 minutes. So, but it's additional time, but in case you will build GraalVM native image, it will also take you between seconds and minutes, depending what you are doing. There is some caveat if you don't, the snapshot will be deleted after 2 weeks if you don't invoke the Lambda function. If you have that pattern with occasionally calling, it's probably SnapStart is not a very good solution, or you need to build some scheduler to do that. SnapStart doesn't support all regions, AWS regions, but the most one, Europe, most one, but it doesn't support several stuff. If you would like to use provision concurrency, like pre-provision environments, it's not possible to activate SnapStart. Maybe it's even not required. It doesn't support ARM64 architecture, which might be cheaper. It only supports x86, the standard one. You cannot bind Elastic File System to use NFS. You can write to S3. For the most applications, it's also not a problem. And ephemeral storage can't be greater than 200, half of the gigabyte. For normal Java functions, I think it can be up to 10 gigabytes, something like this. For me, it's not a bit constrained, but to paint a full picture. So what could be, I don't want to compare GraalVM and SnapStart, the different situations you saw. You can, I think, use both, but that could be my personal next steps with SnapStart to improve it. So this all priming logic, which is the same, needs to be written over and over, and I expect that it can be done out of the box. That it will be open source project that I can figure out what we are using and just generate that logic on demand for you. Yeah, especially AWS can do it for AWS services that require priming, like DynamoDB, so you don't bother with that. And maybe frameworks like Micronaut can provide that ugly code that showed you out of the box to improve it as well. Yeah. I also think that there should be an option for you to trade off, just not to do this snapshot during the deployment time. It makes the developer experience worse. You need to wait more than 2 minutes. I would personally like to have an option to do this snapshot on the first invocation, in case I enable SnapStart. But it should work like this. As long as snapshot is not created, then I cannot benefit from the shorter call starts, but at least then the normal call start should be there for 2.5 minutes, as long as snapshot is not created. Like, yeah, then I will have 3 seconds for 2 minutes and the snapshot is created and can be restored. Yeah, and then I benefit. So I would like to trade off that for the quick deployment, more or less. Of course, it's then the first invocation, a bit worse, or for 3 minutes, but it's not bad. Of course, then the question is if something goes wrong during the snapshot creation, and sometimes it happens. As I know people that have some problems with that, so that snapshot, depending on the application, can be created. I didn't experience that, but it's possible. Of course, you need to consider that. But it's, of course, the trade-off between duration of deployment phase and several bigger call starts until the snapshot is not isn't fully taken. And the same I would apply for the snapshot for the function that are not invoked for the 14 days. Yeah, they should not throw an error in that case, but start the full snapshot in timeout, not error. Start the full snapshot and then deliver. So just do as there were no SnapStart. Normal call starts, snapshot is taken, then activate SnapStart once again, and all behind the scenes will be quite good. Then you don't need to think about invocation pattern of your function. Anyway, if we are talking about call starts to make the full picture, there is that kind of stuff called provision concurrency, that you can pre-provision the stuff that you have you know that you will send newsletter at 9 p.m. and you will have a lot of invocations. You can pre-provision until 9 p.m. lots of warm containers. You will pay for them if you don't use them. It's then up to you, and who can guess the capacity. It's probably difficult, so you will over provision and pay, and it requires manually managing start and end time of that. Yeah, it's kind of the trade-off. You need to know when to start, when to stop. It's sometimes difficult. Interestingly enough, in June, AWS announced more or less in the documentation something like Lambda proactive initialization, which is kind of, it's not up to you, you cannot do anything about it, but AWS will proactively initialize the function instances for you. So they warm up and execute the cold start. So more or less the same as with this provision concurrency, but you don't pay for those. Yeah, but they decide how many. The question was the people would like to measure, and what they measured, they saw that in half of the situation where you had cold starts, now you don't have it because there is a pre-provisioned environment by AWS. Of course, it's not a good feature to rely on because you cannot do anything about it, and AWS can change the rules and say, don't do that. The reason why they're doing this, they're optimizing kind of their own capacity, because they know if there is a huge cold start, they need to spin off all that instances recently, and this also can create kind of stress on the downstream resources or downstream AWS managed services. They would like to avoid it. So they pre-provision, but of course there are no guarantees, but it's good to know that the cold start kind of will happen in the less percentage of cases. So there is more. Java platform would like to improve itself. I can encourage you to look into this project Laden, which runs in parallel, and the goal is just to improve the startup time, type to performance, and footprint of Java applications anyway, especially for the serverless ones, because it's not optimized. So Java itself would like to do that. There was a talk by Mark Reynolds in October at DevOps or some other conference. More or less, they gave the state of it. It's the early stage. I don't know how many years it may take to deliver, but I think also Java will improve. I don't know if that may be possible to improve to the numbers that we saw with GraalVM native image or SnapStart, but at least the best thing that can happen that you don't use anything, simple Java, and you have acceptable cold starts. Let's see how it will go. So this is more or less everything I wanted to tell you. Thanks for staying here. I know it may be a bit late now, nearly 6 o'clock. I hope that it was interesting enough. So I will share the presentations, my presentation. And thanks once again. And I would like now to answer your questions, if there are some. I look into the chat currently. Okay, I think I see one, or even several. I know cold status, even if you use tiered compilation. Yeah, so I'll try to answer. Yeah, 3.5 seconds. It's with all that improvements like tiered compilation, like initializing like the region, giving the region, and all that stuff. Yes. Curiosity, do I have info of comparing Lambda cold starts for Java and other runtimes? As I told you, for Node.js and Python, you can expect between 2 and 400 milliseconds. Go and Rust, I'm not very interested in them because we don't use them. So all JavaScript derivatives will be better. With C#, you will have the same problems, more or less like with Java. Yeah, the same. So I see the question from Michael Fitz. What do you mean by infrastructure, the underlying host of things like the database? Can you give the context of the question? Because it was something in the beginning of my presentation. Maybe you can more elaborate on your question. If Michael stayed here. Okay, probably he's not here anymore. The other question I see, where to find registered events? Also the question to Samito, what do you mean? Is it related to what I talked about? Maybe you can also explain your question and the context. what events you are talking about, then please unmute yourself because otherwise I can't hear you. I will stop sharing. So maybe people left because it's too late. So that unfortunately, I then cannot answer the question because I personally don't understand it. Okay. Yeah, thanks for the people thanking me.